Hi, welcome again in this tutorial video. So in this video, I'm going to discuss representing quadratic functions using equation, table of values, and by graph. So before we are going to tackle each item, let us first have our learning objectives so that it's very clear where are we going to go. So these are our learning objectives. First one, we are going to define what's a quadratic function. It's easier for you now because we are already done with quadratic equation. So the only thing we are going to discuss what's the difference between equation and function. Second, we are going to differentiate quadratic function from linear function. So we are going to compare the function that we are going to learn in this video compared to a function that you already learned a year ago. Third, we are going to represent a quadratic function using equation, table of values, and by graph. Okay, let us start. Let us have the definition of a quadratic function. A quadratic function is a function that can be written in the form f of x. This one, the f of x, this is read as f of x. So f of x equals ax squared plus bx plus c, or a, b, and c are real numbers, and a is not equal to 0. So basically, for us to clearly understand what's a quadratic function, we are just going to go deeply what's quadratic and what is function. So again, it's very easier for you now because we are already done with quadratic equation. So again, why it's called quadratic? Because this is also called the second degree function. So what do we mean by second degree? I think you already know that when we say second degree, you are just going to look at the exponent, and the highest exponent should be 2. So if it happens, then we have a function of second degree. So these are the forms of a quadratic function. F of x equals ax squared, f of x equals ax squared plus bx, f of x equals ax squared plus c. These three equations are what we call incomplete quadratic functions, but they are still quadratic functions. They are just incomplete because, for example, this one, f of x equals ax squared, b and c are equal to 0. That's why it's incomplete. And then for the second one, c is equal to 0. And then for the third one, b is equal to 0. So they are the incomplete quadratic functions, but they are still quadratic functions. Why? What matters most is this exponent. The highest exponent of the variable should be equal to 2. So that's quadratic. That's why this f of x equals ax squared plus bx plus c, that is also the standard form of a quadratic function. Now, let us proceed to the second term, function. In mathematics, function indicates dependence. So what does it mean? When we say dependence, this f of x is just dependent on our input values of x. Anytime we change the values of x, this value of f of x also changes because it is it is just dependent on the value of x. That's what it means to be a function. So since we are going to graph this quadratic function, then we are more concerned with the Cartesian plane, and in the Cartesian plane, we have x and y, and the x is the independent variable, y is the dependent variable. That's why this f of x can be changed into y. So from f of x, it becomes y. And why it becomes y? Because y is the dependent variable. Again, every time we changes the value of x, the value of y will also change. That's a function. So in order for you to determine if it's a quadratic function, you are just going to check if it's a second degree function. So you look at the exponent, the highest exponent should be 2, and then it should be on x. If we are dealing with x and y, it should be on x, not on y. Okay, let us proceed. Since we are done with the definition of a quadratic function, let us now compare linear equation. This is supposed to be linear function versus quadratic function. So linear function versus quadratic function. For you to clearly see the difference, I prepared a table. So if you are going to recall, linear function is of degree 1. Whereas quadratic function, as defined earlier, it is of degree 2. So with this, it's very clear what's the difference of linear function from quadratic function in terms of degree. For linear, it's degree 1. For quadratic function, it's degree 2. Now, I have prepared 4 equations. So what we are going to do is to arrange them. Where should each equation be put under? Is it under linear function or quadratic function? Okay, let us start with the first one. Y is equal to 2 squared plus 3x. Mathematics is full of tricks. When you look at the equation, you might be tempted to say, sir, it's a quadratic function because the highest exponent is 2. And that's one of the most common mistake I encountered. Again, when we say quadratic function, it is of degree 2. When we say degree 2, the exponent 2 should be on the variable, not on the number. It should be on the variable. And what is our variable in this equation? The independent variable is x, but this 2, exponent 2, is not on x. And then, to make it clear to you, if we are going to evaluate 2 squared, that is just equal to 4. So this time, if I ask you, where is the exponent 2? You will just say, it's gone. So meaning, that equation is a linear function. Y equals 2 squared plus 3x is a linear function. Again, do not be tempted easily. The world is so deceiving. Let us proceed to the second equation. Y is equal to 2x plus 1. For this one, it's very simple. If you are going to look at the highest exponent of the variable x is 1. So meaning, it is a linear function. Next, we have y equals x squared. This one is also simple because upon looking, we only have x squared, and it's very clear that the exponent of x is 2 And that's the highest exponent, meaning y equals x squared is a quadratic function. How about this one? Y squared equals 4x. If you are following the video and listening carefully, I already mentioned earlier that the exponent 2 should not be on y, because if it's on y and then we are going to graph that, it will form like this. It's a parabola opening sidewards, opening to the right. So one of the tests to determine whether a graph is a function is to draw a vertical line, and this vertical line should only hit the graph once. Once it hits the graph for more than one, it's not a function. That's why this one, it's neither a linear function nor a quadratic function. So, bye-bye.
Paalam aking mahal.
I think it's clear to you now. I hope so. So we already differentiate linear function from quadratic function through their degrees. Now let us proceed to table of values. For table of values, I think you are familiar with this. You are going to construct a table, values of x and y. So let us start with linear functions so that we can recall. You might probably forget how you are going to construct a table of values. So consider the given linear function y is equal to x plus 3. So this is our given function y is equal to x plus 3. And then we are going to construct a table. So for our table, it is composed of two rows. One row for the values of x and another row for the values of y. Again, x is our independent variable. So meaning we can assign values for x. So in my case, I want x to be negative 2, negative 1, 0, 1, and 2. And again, in this one, I'm going to show one property about quadratic function and linear function. So I make sure that the difference between my values of x are the same, so that we can see the pattern. Now, when it comes to y, we are going to solve. So, for example, if x equals negative 2, we are going to substitute. Instead of x, we are going to substitute that by negative 2. So, we have negative 2 plus 3. And that is equal to 1. That's why, if x equals negative 2, y is equal to 1. So following this method, just substituting the values of x, we can get the following values. If x equals negative 1 plus 3 is equal to 2. If x is equal to 0, 0 plus 3 is equal to 3. If x is equal to 1, 1 plus 3 is equal to 4. If x is equal to 2, 2 plus 3 is equal to 5. Now, we are done with our table of values. Next thing we are going to do is to find the difference. We are going to subtract the values of x, and in my case, I'm used to doing it from right to left. So meaning I will subtract 2 by 1. 2 minus 1 is equal to 1. Next, we have 1 minus 0 is equal to 1. 0 minus negative 1 is equal to 1. You should be careful on this because one of the most common mistakes I encountered, the students always commit mistakes when it comes to integers. So for this one, we have 0 minus negative 1. So 0 minus negative 1. If we are going to solve that one, applying the rules, instead of subtraction, we proceed to addition, and then add the opposite of the subtrahend. Opposite of negative 1 is positive 1. That's why it becomes 0 plus 1. That's why 0 minus negative 1 is positive 1. And negative 1 minus negative 2 is positive 1. So what do you observe? Differences are equal. So that's what I said earlier. Because I'm going to show a property, I make sure that the difference between my values in x are equal. So I'm just showing to you that they are really equal. Next, we are going to subtract the values of y. Again, I'm used to doing it from right to left. So if you are going to do it from left to right, it's okay. As long as you do it left to right in x and in y. So for me, I'm used to write from right to left. 5 minus 4 is equal to 1. 4 minus 3 is equal to 1. 3 minus 2 is equal to 1. 2 minus 1 is equal to 1. So again, what do you observe? The differences are also equal. So with that, I have shown to you the property of a linear function. In a linear function, equal differences in the values of x produce equal differences in y. So meaning, if the values of x have the same differences, it is also expected that in the values of y, the differences are also equal. If they are not equal, meaning one of your values is wrong. Okay? Okay, let us proceed. For quadratic function, let's have quadratic function. So for quadratic function, we consider the given function y equals x squared. So I just choose a simple function so that we will not have difficulty understanding this video. Again, construct a table of values. For x, I choose these values, negative 2, negative 1, 0, 1, 2. Again, we can choose values because x is the independent variables and it depends on who is solving. So since I'm the one making this video, I want my values of x to be that values. But for y, we need to solve. So if x is equal to negative 2, what will be the corresponding value of y? Again, you are just going to substitute. So you will have y equals, your x is negative 2, so you will have negative 2 squared. And what is negative 2 squared? It means negative 2 times negative 2, meaning if x equals negative 2, y is equal to 4. Now, if x is equal to negative 1, y is equal to positive 1. Why? Because negative 1 times negative 1 is positive 1. If x equals 0, 0 squared, 0 times 0 is equal to 0. And if x is equal to 1, 1 squared, 1 times 1 is equal to 1. And if x is equal to 2, that will become y equals 2 squared. And 2 squared is equal to 4. Yes, now we have our table of values. Next thing we are going to do is to subtract. Again, I'm used to doing it from right to left. 2 minus 1 is 1, 1 minus 0 is 1, 0 minus negative 1 is 1, negative 1 minus negative 2 is 1. And the same question, what do you observe? The same answer, differences are equal. And then, let's proceed to the values of y. What is 4 minus 1? 4 minus 1 is equal to 3. Next, 1 minus 0 is equal to 1. So with that alone, you can say, oh, it's different. How about the next one? 0 minus 1. You should be careful on this. When you have 0 minus 1, 0 minus 1, that is equal to negative 1. It should be negative 1 because what I encountered, some will just answer 1, and with that, you cannot find the pattern. 0 minus 1 is negative 1, 1 minus 4 is negative 3. So, in this lesson, operating on integers is very important. That's why it should be mastered during your grade 7. The operation on integers. Now, what do you observe? Observation, the differences is very clear. They are not equal. 3 is different from 1, 1 is different from negative 1, negative 1 is different from negative 3. But there's a saying that you give a second chance. Or if you don't like that, try and try until you succeed. Because our aim is to have like this, wherein the differences are equal. So let us give the values of y a second chance. Okay, so what is differences are not equal. Okay, let's proceed. 3 minus 1 is equal to 2. Yes. Next, 1 minus negative 1 is equal to 2. You should be careful with the signs. 1 minus negative 1 is just the same as 1 plus 1. Next, negative 1 minus 3 is also equal to positive 2. So this time, what do you observe? They are now already equal. So, this group of differences, we can call them as the first differences. First. And this one, the spinning differences, the equal differences, we can call this as, oh my god, my two. The second differences. So what can we conclude? Therefore, in a quadratic function, equal differences in the values of x do not produce equal first differences in y, as I have shown to you. Instead, the second differences in y are equal. They are all equal to 2. So that is one way of checking if the given table of values is a quadratic function. You are going to find the differences. So if you find the first differences, for example, this set are all equal, meaning it's just a linear function. But if they are not equal, you proceed on the second differences. You give him another, not him, you give the function another chance. And then if they are already equal, meaning it's a quadratic function. If not, then it's not linear, it's not quadratic. Maybe the next type of function, and it's not our concern. So okay, so now let us differentiate linear function from quadratic function. Differentiate. the question is, if the differences in the x values are equal. So this is what I stated earlier. The differences in the x values should be equal so that we can see the pattern. The question is, when are the differences in the values of y equal? Okay, for linear function, when it's on the first differences. But for quadratic function, it should be on the second differences. So there will be exercises on your modules about this one, wherein you're going to determine which of the following table of values describes quadratic function. So what you're going to do is to do what we did earlier, what I have shown to you. Do not be lazy. Okay, next, we are on the last part, representing quadratic function by a graph. So for us to recall what's the graph of a linear function, let me show it to you. Consider the same function y equals x plus 3, and then we have the following table of values. I just copied it. So the same table of the same values. So if I'm going to graph that one, it will look like this. So if you are going to verify if it's correct, for example, the first coordinate, negative 2, 1, it's on this point, negative 2, 1, and then negative 1, 2, 0, 3, 1, 4, 2, 5. So 2, 5, this is that point. And then if we are going to connect, it forms a straight line. That's why it's called linear function, because the graph is a straight line. So we conclude the graph of a linear function is a straight line. Next, let us proceed to quadratic function. It's new to you, quadratic function, and it's fun graphing quadratic function. Consider the given quadratic function, the same function, y equals x squared. And I just copied the table of values. And then when I graph it, it looks like this. It's a smooth curve. So again, let us check the points if they are correct. Negative 2, 4. Negative 2, 4. That point. Next is negative 1, 1. Negative 1, 1. Negative 1, 1, my favorite hero. And then 0, 0, that's the origin. And then 1, 1, my favorite hero again. And then we have 2, 4, that's that point. So when I connected it, it forms a smooth curve. So this graph, this is called a parabola. So the graph of a quadratic function is parabola. Okay, with that, we can now compare the graph of a linear function and a quadratic function. So let us compare. Okay, the table again. Linear function, the graph is a straight line. It's a straight line. For quadratic function, the graph is a parabola. It's a smooth curve. So on my following videos, I will teach you how to graph a parabola. So I think that's all for this video. We already represented quadratic function. So as I recall, quadratic function in terms of equation, it should be of second degree. In terms of table of values, if the differences in x are equal, it should be that the second differences in y are equal. That's for quadratic. So quadratic, degree 2, second differences. So you see the pattern. And then for the graph, it should be parabola. So again, thank you for watching, and I hope it helped you. So thank you again for watching, and thank you for watching again. Bye bye.